All right, hi everybody. My name's Christopher Sawyer. With me is Bodo Bachmann. This is Bodo over here. Welcome to Modernizing PySQL for the Future. If you need to reach us, Bodo has the coolest email address ever. So it's just bodo@osisoft.com. We have like about 7 other employees that have like Bob or Chris or Ray. But Bodo is one of the longest serving engineers in the company. I'm like 13 years in, so not quite that long. We've both been doing SQL for quite a long time at OSI. So if you have, how many of you are currently using PySQL in some form? Raise your hands. Good. How many of you have been using it for more than 5 years? Okay, cool. So this will be awesome for you guys because we have a new version of PySQL that is basically based on a new engine. It's called the real-time query, or it was RTQP is what we call it. The real-time query, what do you want to call it? Processing?
Yeah.
Yeah, I can't figure that acronym out, but basically it's a redesign of the engine underneath that handles your PySQL statements that you're currently doing in ODBC and ODBC Enterprise. So what is the reason behind the product to begin with? You have line of business applications in addition to what you're doing in the Py system. Nearly all of you do. And you're going to have things like, for example, in energy, or if you're a consumer of energy, you're going to have things like rate tables. How much am I paying per unit of energy? That kind of stuff, that business stuff, in most enterprises is going to be stored and maintained in SQL. And it's not data that is really suited for Py in a lot of situations. So there's going to be a need to marry that. Going along with that, you're probably going to have some sort of app, or you have several apps already, where you're taking streaming real-time information and enhancing your existing assets that you've got stored in your line of business apps, and you're trying to do what's called a mashup. So if I have a particular type of asset and I have all of its business information that all my business analysts see, what I don't have in SQL, in a traditional SQL Server environment, I don't have what its current consumption rate is and how it's behaving, because that stuff is in Py. You want to be able to merge that stuff together. You also want to do the flip side of that, where you have your line of business data and you might want to do backflow. So that's another possibility, and that's a common business case that we get with PySQL. And one thing that we have always been doing in SQL, and it continues this day, and it'll probably last forever, is that a lot of you are still doing your data analysis in SQL. And if you're not doing your data analysis there, and you are still doing most of your transaction processing there, or you might be doing your data staging in some way, shape, or form. So SQL is never going to go away. And we already lived through that era of NoSQL, that fad, and everybody saying, yeah, we got Cassandra, we got Hadoop, we got all this other stuff. SQL go away? Nope. Is it ever going to go away? No. And we are committed to always being able to tightly integrate with SQL because you are tightly integrated with SQL. I am going to go ahead and quit yapping and switch over to Bodo, who's going to show you all the upgrades and performance improvements we've made.
All right, thank you, Chris. So, well, first, also the question, how many people were using PyODBC Enterprise? And, yeah. This talk is about our new query engine, but I will reference PyODBC Enterprise, kind of the predecessor, a few times, just to show our progress that we made. So why did we develop that new generation of query engine and client drivers? I'm going through the list. One was performance and scalability. I mean, that's always a good driver. But it also means we had problems before. So PyODBC Enterprise was well developed, but it had some issues. For example, it was including the query engine in the driver. You had to basically run the query in the driver, which consumed a lot of memory. And before you got any result, you had to kind of create the result set in memory. So it was consuming a lot of memory. Scalability and performance was a problem a little bit because it runs on the client side. So depending on what connection you have to the server, everything had to be transferred over to the client. Whereas sometimes, you just need 1 million of intermediate results, but at the end you come with one row. So we were addressing this in a new architecture. We also had complaints about our data model. I mean, we did it in the standard way, a normalized data model where you have many tables and the tables did not contain duplicate data. Was according to the theory, but for engineers maybe not the best. So our idea was we should reduce that query complexity, I mean the need to write complex queries a little bit, and compromise, so with the table design. We also, when we started with our new engine, that was like 3 years ago when we really kicked off the project, we asked a lot of customers. So we had a CTP project where we asked what are the main use cases, what are your priorities in terms of functionality, what should we do? So we included our customers in that process. And we also addressed a number of issues that we had learned over time. So things like how do you handle pi time literals, which is not really something a SQL data type would understand. So what is a star or a T or a Y in terms of SQL when you have a data type question? So we originally had a time data type there. It is a numeric data type, so it does not know what a star is. So we changed that. Infrastructure to support multiple standards and thin clients. So we changed our architecture. We have the engine on the server side, and the clients are basically just implementations of the industry standard. So the client is JDBC interfaces or ODBC interfaces or OLEDB interfaces, but it does not do more. It's actually a thumb client. It's something that delegates the work to the server. That has a lot of advantages in terms of working across wide area networks, because the client is very thin. It does not do much, and also the communication on the network is highly reduced compared to using an AF SDK connection, for example. And we also had some issues with security and authentication, especially in the architecture where you had a middleware in between. So you had these Kerberos double hops, which caused some people pain to configure. So we now in this new environment still using Kerberos, but there's no configuration involved anymore. So this is the components that we're talking about. These grayed out things, these are the other two data access server versions that we have. The first one is using OLEDB and OLEDB Enterprise in order to make it available to PyJDBC and PyODBC. That's the part we are not talking about in this talk. And then we have this new version. RTQP engine was mentioned, stands for Real-Time Query Processing Engine. It's a service that runs on the AF server. It's also included in the PyServer setup. So when you want to use it, you run the new PyServer setup and enable this optional module there. So there's not anymore a possibility that you can install it on any other machine. You have to install it on this AF server machine. That has a number of advantages for us. First of all, we don't have to test cross-version functionality. So version 1 of Data Access Server with version 2 of AF Server, or version 2 of Data Access Server with version 1 of AF Server. That's not needed anymore. Each AF Server brings a new version of the Data Access Server. And then you have these clients. In 2018, we did the first release of the server and the client. That came with an ODBC provider, and just this week, you heard it on the first day that PyServer 2018 SP2 was released, and the PySQL client 2018 R2 is coming in a few weeks. But you can already use the 2018 version of the client, which contains just the ODBC provider with that new 2018 SP2 server. So again, the architecture now looks like this. You have this RTQP engine. Everything goes into that RTQP engine, and then it talks to the backends. Before, we had the situation that the client contained the engine. The engine was based on AF SDK, and you may know that AF SDK for data references makes direct communication to the data reference data source. So you had a connection maybe to the data archive, which was running on one machine. And then for everything else, you had a connection to the AF server, which was running on another machine. So that was kind of a problem, because the connection to the data archive depended on your default server, maybe. If you have used relative server names in there. This is now much more easy to configure, and also confusion about what data archive server I'm using if I have multiple ones is more clear. So deployment is one thing that I just mentioned that we are now making different. We also learned that we need to really make a difference how we treat the internal data sources. If you look at a relational database, then you can actually assume that data from table 1 is having the same retrieval speed as data from table 2. In our world, that's not the case. I mean, PyPoint data reference has a different speed than a ODBC data reference, than maybe another custom data reference. So we have to take this into account, and first look at what data do we query, and in which order should we retrieve it? Should we retrieve it in parallel, or should we retrieve it in a way that the fastest data reference is queried first, and then it parameterizes the next data reference if there is a filter condition. So this is something for the optimizer that we added to the engine. We also have to take care about this memory management. Since we are now having only one query engine and not every client has its own, we need to make sure that we are not overflooding, overusing the resources that are on the AF server. I still need to say that the AF server, which could previously run on a very, very small machine, because actually it did nothing than delegating requests to the SQL server. Now it runs the engine and needs much more memory. So instead of 2 GB main memory, you should maybe have 20 or more. That's in the documentation, but who reads documentation? That's why I'm saying that. Intermediate results is something that we are also trying to optimize. So if you have a query that does not do any additional sorting, then the result is directly sent to the client, and that's where the streaming part comes in. You can access the first rows nearly immediately. So if you expect 100,000 rows, then you get that in pages. Whereas in ODBC Enterprise, you got the first row when the whole result set was in memory. Now you get already the first part, the first section, as soon as it is available. Whereas the query engine still works on retrieving backend data. So that's an important improvement, and that's also part of our performance improvements when you look at how quick you get the data. And yeah, security, I also mentioned that we did some changes there. So the Kerberos double hop problem is not there anymore. We actually did that by using the service account from the RTQP engine to retrieve data from the backend. And when the data arrives in the query engine, then it applies the AF security on it. So in ODBC Enterprise, it was made in a way that part of the authentication was done in the engine, another part was delegated to the SQL server, so there was some overhead. Now we are really, going with a God account, if you want, into the backend and apply the security on the query engine, which is much faster. So we did also changes to the data model. The first thing is we have a connection to one AF database. If you use multiple ones, then you need additional connections. In PyODB Enterprise, it was done with one connection, so you had catalog equal AF database. Now we have connection equal AF database, so we have more freedom on what we use for catalog and schemas. There is this master catalog, which contains all our predefined functions and tables, and a user can freely define additional catalogs and sort custom queries in there, as well as creating schemas underneath. Elements and event frame tables are there as well. Attributes and data tables are there. They are a little bit differently organized in the schemas, but they're very similar to the ODBC Enterprise data model. What we did different there was the denormalization. I mentioned at the beginning that the data model is now a little bit changed to make query building more simple. We introduced something we call navigation columns. That's actually a term from OData, whoever heard about that standard. These navigation columns are columns that you can use to navigate to another table. So, for example, in the attribute table, the element name would be a navigation column, because you can take that name and go into the element table. And then we introduced these template, or actually we improved the template-based table value functions. That is something people use a lot for reporting, because the normal tables deliver you the data in a way that you have many rows for attributes, and then you just have a value column. Whereas reporting works in a way that you use a column per attribute. So that's what we call a transpose mechanism. So we basically do a 90-degree transposure of the original table, and we do that based on templates. So only for templates at the moment. So that if you have an element with 10 attributes, you will have a resulting table valued function that has 10 columns. So the result of that is something like this query. I mentioned that I will reference PyODB Enterprise to show the improvements. So original query was fully normalized, but required 2 joins. The new query omits all these joins, because it has in the element table a template column, so where you see the template names. So now you can just say, okay, give me all the elements that belong to boiler or heater. And if you go a little more deeper and also want data, then the next example shows you that you can further reduce the query in a way that the snapshot, which was an own table in ODB Enterprise, is now part of the attribute table. So the attribute table does not only contain the metadata for an attribute, it now also contains the snapshot values. So you save another join in there. Custom objects is an important part of our design, which makes it very customizable. So you can do different type of use cases with SQL queries here. And to simplify that, or to simplify that for users, we have always had views as a possibility. So you can wrap your complex query into a view and just continue using this view. But we now also have custom functions, so you can create a parameterizable query with these custom functions. And we have these custom table valued functions because they are all going in a template-based way. We are having a wizard in our environment, our development environment, and you can easily create that rather than really typing the create view statement or create function statements. So to make that more clear, I have demos for it, so we don't have to really go in detail here. And then I would like to say a few words to our clients. And in the 2018 R2, which is coming in a few weeks, we will see this screen when it goes for installation. What is interesting here is there is only one dependency there, which is Microsoft Visual C++ 27 redistributables. So our runtime that we are using. And then you already have the clients. So there is no AFS SDK in there, no other Pi library that you need. It's very thin. And in this version, you have the main drivers that we intend. Maybe in the future, we will add a .NET managed provider. But I think that's already going very far. And then we have the PySQL Commander, which is our development environment, the tool that you can use for creating queries and testing queries. So when it goes for making a connection, there are several options that you have. I mentioned that you have a connection per database. So we split the connection information into AF server name and AF database name. That's something you need to provide to make it more convenient. In case the Pi Web API is installed, you can use a drop-down mechanism. So you don't need to remember your AF database names. But if a Web API is not installed on the AF server machine, then you need to type that name in. Then there is, on the right-hand side, time zone support and query date. That's something we have added to the new clients. Time zone was something we didn't have before. It is in an enterprise normal that you have the server in one time zone and the client in another one. We are now supporting this by providing the time zone via the client connection string. The standard setup is local time zone. So we actually don't, if you don't do anything, then we are working in local. The server runs in the server time zone, but gets the information from the client in what time zone the query is and what the returned data will need to be. But you can also set any time zone that you find useful for your application. Maybe you have a middleware application, a web portal or something where you connect clients from or browsers from other time zones, then you can manage that in your connection, delegating the time zone from the client. The ODBC provider is typically used for SQL Server integration or reporting tools. Also very nice in ADO.NET and ASP.NET. If there is any older applications there, then ADO itself or VB6, all supporting ODBC nicely. The ODBC driver is more used from BI tools. Most of the BI tools have ODBC support. A few of them have ODBC support, but that's where we see most use of the ODBC driver. And ADO.NET, ASP.NET has the same type of support. There's actually not a big difference. They all go via an internal conversion. ODBC is not a .NET standard as well. ODBC is not a .NET standard. So there is some conversion. That's why we actually think about doing a managed provider. But the integration is seamless, so it works nicely. And then we have JDBC there. We have this new JDBC driver implemented in pure Java code. So there is any runtime or any platform that has a Java runtime we are supporting. And when I say Java runtime, then I actually mean Oracle Java runtime. There are some others there. So typical, Linux distributions have that. Oracle Solaris, of course, and Mac OS and Windows. Yeah, and then we have PySQL Commander as part of the client setup. This is for learning the data model and looking at what functions we have. I go through in the demo. We have this compendium there, and we are working to have some code completion in there as well in this new version. So you can start typing your query, and it's automatically making suggestions about how the query should be completed. Performance-wise, again, the comparison to ODBC Enterprise, I'm very often asked, how many times faster it is. It's difficult to say because it depends really on the query. If it's just a call to a PyPoint data reference, then the speed might be the same because we are still using the same AF SDK calls underneath. Depending on the AF server version, maybe we are using a bulk call or not, or actually the data archive version. But you can assume the same performance. When you have a AF structure that is a little bit more complex, then there is much better performance. So here in this example, we're having a query that looks at attributes that hold the GPS coordinates. So it's kind of a query that says, give me all the data in this region. GPS coordinates are values of the coordination Y and X axis. And so it's actually a search, not only by metadata, it's a search by value. And that's very hard to optimize. So we achieved kind of a reduction in the query execution time here from 5 seconds to 2 seconds, which is quite a lot if you think about the problems behind. And so this is about the average performance improvements that we have seen, so like 3 times, 4 times faster. And then there's these extreme cases where we can be 50 times faster, especially when we use the streaming capabilities. For example, a top 100 can be much faster because in the previous version you had 100,000 rows and you only needed the top 100. You had to wait until all the 100,000 were calculated. So in the future, we also have some plans, no schedule yet. One is supporting locale property. You can use these string literals in the so-called invariant form, then you just use English language for dates, for example. But you can also localize it and, for example, use your local regional settings. Then you have to prefix it with N. N is a standard, means nationalized, and then in this case it's a German date. We have already worked on data archive implementation, so you can, for example, make a query that retrieves AF attributes plus PI tags. So if you not have all PI tags configured in your AF structure, but they still, belong to a certain element, then you can then make a query that kind of appends the missing attributes via direct PI tag access. So imagine you have a unit where you have 100 attributes, but actually you have 1,000 possible, sensors on it. Then, first of all, it would probably be a scaling problem for AF to configure them all on an element, and then maybe you only need it for a few queries. So that's the biggest use case I see here. And then the other two are about write direction. So current version is read only, but we have requests from customers that we should make it possible to write event frames directly via queries, insert or update, delete them, and the same with tags and attribute values. So that's our plan for the future without having a schedule at the moment. If you think that is a priority for you, email me. I will record it, and chances are that as more customers want it, as earlier we get it. So demo time. How are we in time? Mm-hmm. Are we good? Yeah. Okay. So the first thing maybe I want to show you is an ODBC data source. How it looks like with our new ODBC driver. I mentioned that we have here AF server name and database. Here there is no PyWeb API installed, so it gives you a message that you need to type it. Right? If I would use a different server, I think maybe this one has it installed. Yep, then it works this way. The other interesting part is here in the advanced button. Time zone I mentioned. So local is the default, but you can choose from any of those that you know maybe from Windows regional settings. And then it means that every timestamp that you put in your query is considered in that time zone, as well as the result will be in that time zone. So it's not only the result that the return is in that time zone, also the strings and other, also for parameters, it's true that it's then in this time zone. So most use cases probably here to use UTC. So going back there. And another thing that we have is query date. We dropped the idea of full support for versioning, AF versioning, because we have not seen too many customers really using it. But in case someone has different version, this is in the connection, the query date that you can provide. So it works similar to the PySystem Explorer. You say what time you want to see your hierarchy, and then it works with that hierarchy at that point in time. So in here we have just workarounds for third-party tools that don't support variants, for example, or don't support the GUID data type. In this case, you can just make them available as strings. So, and here we have our PySQL Commander Lite version, and it still supports the old ODBC providers, Enterprise and Classic. And here is ODBC for PySQL client, and then here is ODBC for PySQL client. So I have already made a connection, so it remembers it. I'm double-clicking on it, getting my connection box. For ODBC, you see the same settings being available as for ODBC. You can here make a test connection, and when I connect, then I see that master catalog that I mentioned. We have these predefined schemas, categories for AF category tables. We have element schema and event frame schema. They also include the corresponding data tables. So if you see here, there's an archive table here. Then you have attribute element table and some others, like the hierarchy. In comparison to PyODB Enterprise, we have moved more data tables into table-valued functions because actually that fits better the SQL model. So there is things like get summaries here or get summary. Plot values, they're all table-valued function, which means actually that you have to provide some parameters to it to configure it. Because you can have different types of summaries, and it's all represented by one table-valued function. So a table-valued function compared to a scalar function is just the difference that the result is a table, whereas for a scalar function, the result is a single value. And then we have here, what is new, we have these templates. And these templates are actually directly usable, or they are used by the wizard to create these table-valued or these custom table-valued functions. Something that I will demo because it's a little bit more complex when I need to explain it, so I better show it. And here I have already created a custom catalog, my views, so you can freely, add views or functions. There's actually nothing in there. So let me see if I have something here. No, they're all empty. So when you just create the schemas, they're at the beginning empty until you put something in. So let's start with a table value function. What I wanted to show is our wizard that creates it and guides you through the process of creating this table valued function. It lists all the available templates, AF templates, so you can either do that for elements or for event frames. I'm just using a boiler here template. And then you have here the list of available TVF types, table value function types. I'm using summaries. When you click it, you see the list of available attributes on that boiler template. And you can just drag and drop attributes into this part. What that actually means, with every row that I'm adding here, I create a number of columns in my new table valued function. So here I select the summary type being average, and it automatically completes the remaining columns. So the value will be a resulting column, and the unit of measure will be a resulting column, error will be a resulting column, and desired unit of measure. I don't want an error column, so I just unselect it. What I actually want to do for this example, I want to have my fuel fuel gas flow in 2 different unit of measures. So I'm dragging this fuel gas flow another time in here. Choose average as well. It shows red here because I would have duplicate column names. So I'm correcting this by just adding a 2 in here. What I don't want is this long column name for UOMs. So make it a little bit simpler and call it UOM2 and UOM. So you can, really tune that to your preferences. And I also want to give it a different name for the table valued function. Call it fuel gas flow average. Oops. Oh, this is a German keyboard on an English computer. Okay, fuel gas flow average. Okay, and to make it really a difference, I want to have a different desired unit of measure. So I'm choosing cubic meter per. Okay, now I need to find out where that slash is. Certainly not this one. Where the hell is the slash?
See where it says ENG at the bottom?
I try everything here.
Oh, there you go. Okay.
No.
I do the same thing. I just swipe the keys until you find it.
Yeah, exactly. So this is really boring. If anyone has an idea. Maybe not, I can copy it somewhere, from somewhere. Yeah, that's maybe a better idea. I go here. Oops, take a notepad. Where's my notepad? Yep, put in a slash in here, and there we go. Okay, so that's how it works. I will keep that in my memory and say OK. And if I go to the next screen, it creates me that create function query. So we can see what it does. It has 5 parameters that I need to provide when I'm using that function. The element ID, start end time, time step, and time type. And here is the definition of using the get summaries template. So I actually have 2 sections in here corresponding to the 2 attributes that I was using. So if I execute, it's storing this in AF, actually in the configuration database there, and remembers it forever. So if I look here in my table valued functions, I have that new added. So I can look at parameters here. There are those 5 that I mentioned, and these are the resulting columns. So I have a timestamp, the fuel gas flow average value, the UOM, another fuel gas flow average, and another UOM. So the nice thing, I can just make a right click, execute predefined query, and test if it's doing what I was expecting. So I see my fuel gas flow values in feet, square feet per second, and I see that in square meter, cubic meter per second. And the query that this predefined query is doing is exactly filling out these parameters here. the predefined query just makes an assumption. You can, of course, modify it to what you like. But this is really for quick testing of a query. It uses reasonable values, so it's not querying for 1 year. It just takes 1 day, and time step is 1 hour. That's just a decision that we make as part of our commander. And the way these table-valued functions are used is using a cross-apply. That is the same as using an inner join with a table. So now, what can I do? What else can I do with this function? I can modify it. So there is a alter function in here, and if I use that, the whole thing, the create function, gets changed into an alter function, and I get this complete definition here. And now I can do some changes. For example, I would like to get liters instead. So I can execute it. Yeah, I don't get any results back, so that's why my affected row count is -1. I can here say a refresh and see if my new boiler fuel gas flow average is using liters. Yes, you can see it here in the tooltip. And I can just rerun that query here and see if it works. Yeah, so I'm seeing liters now. The values have changed. Something pretty nice. So what else can we do? We can maybe simplify that table-valued function further. If you, for example, always use the same start and end time or the same time step or time type, then you can wrap that in another function. So I'm having something prepared here already. So here, I want to reduce my 5 parameters for that fuel gas flow average function, and I create an average 2 function out of it, which only takes 3 parameters. The element ID and start and end time, and I want to hard code the time step to 1 day, and everything should be most recent time. So a nice feature of the commander is that I can just press Control R, then it automatically selects the query on my page and executes it. So I should now have a fuel gas flow average 2 TVF. If I refresh it here, it's there, and you can probably see that it only has 3 parameters. So here is how to use it. Again, using that cross-apply, using average 2. And I'm this time doing this only for 1 element. So Control R again, and here's my result. These table-valued functions, or they are created typically by an administrator maybe, and there is some security settings to do on the AF server. If you don't want to go through these create function steps, you can also do that ad hoc. So here is how you would do the same query using the template, which you can find here in the templates. So this get summaries template is used with these type of brackets. So you provide the information that actually the wizard provided before, and you can, without having these fuel gas flow average functions, you can actually execute that directly, and it should return the same things. So here I don't have the UOMs included, but you can see here, based on the commands, which columns are optional. Okay, so this is so far to this complex topic of table-valued function and creation of those functions. I hope I could make it clear with the demo. You also have a demo?
Yes, sir.
Yeah, so then we can switch maybe?
Yeah. Good time to recover?
Yep.
Okay.
Go around.
Okay. I don't know, maybe my demo's not as exciting, but we'll see.
I'm not sure if this was exciting. It was at least some complexity, I guess.
One of the things that keeps me in PySQL quite a bit is its ability to integrate with esoteric things. And I want to give you an example of that. One of the things I wanted to cover is, this is a common request that we get. Do any of you use linked servers, or basically PySQL as a remote on Microsoft SQL Server? So we have one. Anyone else? Okay, this is good. So I'll show you a trick. Basically, it's bridging, which is taking PySQL. You could also do this in PyODB Enterprise, and you link up PySQL as a remote server in Microsoft SQL Server. The purpose being is that, I mean, we already have drivers. We have the ODB provider, we have the ODBC driver, we have the JDBC driver, but there's a lot more manufactured drivers that are basically talk to SQL servers that are out there. So if you're dealing with something, let's say, like a third-party tool or like Maximo, this may be a solution for you. So I'll just jump right into it. If I can remember my password. Woo! Worked. Okay. So this is something that I would typically do is work on some simple little query in SQL Commander to get some spot of data. Something that I know I want to share out to an application out in the world somewhere. What's really cool in SQL Commander is that I can create new catalogs. So besides just master is where everything is, by the way. I can create another catalog and then put my specific types of finished products, my finished queries in there. And then that way, when I give that over to my data analysts, who are SQL gods, they are not overwhelmed with all the other stuff that is inside the master catalog. So I can narrow that down to stuff that I know is working. In this case, I'm not going to do that. I have pulled all the fuel gas flow for all the boilers here. And that is the snapshot value. Unfortunately, it's all the same because that's basically just the sinusoid tag. But what is really nice in this new version is I can jump straight into SSMS, and I'll be able to paste that there as a query. But how do I get to, I'll delete this because I did that before. How do I get to PySQL if I'm in Microsoft SQL Server? Let me collapse all of this here. So if you go onto your SQL Server, you can just install on the SQL Server the PySQL client. And then you're going to get a new provider under linked servers. And this is the provider. And this is the one that will also get you access to the RTQP engine from inside Microsoft SQL Server. So all you have to do is create a new linked server here. We'll give it a name. And then make sure you select the right provider. So if you've also got ODB Enterprise or ODB on there, you want to use the PySQL client. So make sure you pick that off. Otherwise, you're going to have a bad time. Let's see. I believe the AF database I want, I put here. For the provider string, it's going to be security equals SSPI. The location will be the host name. And if you created your own catalog in SQL Commander, you could specify that here. In my case, I'm just going to default to master. Then over here on this screen, I can actually specify which, if I've got a mixed mode SQL server for mixed mode authentication, I can attach SQL Server accounts directly to roles, or I can set up pass-through impersonation. Any of those types of options can be made here on the screen. For right now, I'm going to accept the defaults. Then you're going to have a new linked server here. Theoretically, if you open up the master catalog and start looking at the tables and the views, now you're connected to the Pi system from within Microsoft SQL Server. So if I go back to SQL Commander, and I'll go take the query I was working on, I'll go to my line of business database. It's just a blank SQL database. It's really got nothing on it. I'll create a new query. Actually, I've already got that query open. I'm just going to dump this here. Now, this won't work right off the bat. If I execute this, it's going to say can't find it. What you got to do is this. Put the linked server name there. That fills out the path. There's your data. Very easy. And what's nice is once you've patterned this the way that you want, you can take, like for example, if you're doing time series buckets and then you're marrying that with your accounting periods, whatever your data analyst wants, once you have that massaged and mashed together the way that you would like, I usually just create a new SQL view, or instead of using that GUI, it's just easier to do it this way. Whoops. Create, if I can spell it. This should create a SQL view. There it is, fuel gas flow. Boom, there it is. So now I'm not even in PySQL anymore. Now my data analyst, who is a SQL guru, can go to town with it. But take it one step further. Let's say you want to consume that in something that you can't get the PySQL client on. So I'm going to go over to my Mac here. And let's try putting it in something weird. I got this working this morning. Let's see if it works again. Let's see. I have to wait for the screen to draw. It's drawing over there. It's not over here. I might have to disconnect and reconnect to get that working. Let's try reconnecting. There we go. It's a congested Wi-Fi network. There we go. There's Microsoft. This is Microsoft Excel for Mac, which just got put on my machine this morning against my will. And it upset my, there's actually a thing as, such a thing as ODBC drivers for Mac. So there is this company that makes it. They make drivers for Sybase and SQL Server. And then there is a little ODBC tool. Now I've already pre-made a ODBC connection, but they've patterned the wizard right off the same ODBC wizard that's in Windows, which is kind of neat. And Microsoft basically saw this, and then they said, hey, can you use this to support our product? Thanks, we'll give you some money. And so I'm not pimping this at all. I'm just showing you that this works. So I'm going to go in data. or actually it's this data, get external data from a database. And this is connected to my SQL server. And there's that view that I had just set up. There's the data, all those boilers. There's snapshot values. Boom. Right there in a totally alien product that OSI doesn't have direct support for. But now you can basically use Microsoft SQL Server as a conduit to get your Pi data anywhere you want it now. And there is a .NET Core driver. So basically every edition of Linux that is current, there is a native Microsoft SQL driver out there for it now. There's adapters to just about every data science product that will connect back to SQL Server. So if you can't get bridging to work directly through our Pi SQL client, you can do that adaptability this way. And that's the demo.
How much difference is there if you do have the choice between directly using the ODBC client versus going through?
Well, there's an issue of performance, but you are going to pay a small price for that hop. And by the way, this is read-only. So normally you would be putting a finished product, so you'd be doing your data mashup, and then maybe if performance was an issue, you probably would want to do some type of ETL job, and then put that over in a more high-performance table, and then push that out if you're worried about real-time performance there. But we're talking about really large volumes, because if you're using the RTQP engine, you're going to notice a sizable increase in performance already on reads. It's going to be the same speed that AF is reading, for the most part. Do you want to take back over?
Yeah.
Okay.
Let's see, do we have...
Actually, I think that might be...
Yeah, we don't have...
that was the full demo?
That was the demo, yeah.
Okay, cool.
Unless we want to, look at any more things based on questions.
Yeah, when we put this talk together, we envisioned that we would get a number of people coming up to us with all of their SQL gripes and headaches. So we'll turn this over into an Ask Me Anything session. So fire away. Anybody have questions? Yes, sir.
Yeah, so at our company, Anheuser-Busch, we're doing a lot with SSIS jobs, and we're trying to look at some of this integration. Would you guys recommend using kind of the methodologies you used earlier in terms of, I'm not sure if this is, she's trying to get working, in terms of trying to get it to work with with SSIS jobs and trying to use the RQTP engine?
So are you doing mostly just like extract, transform, load, or are you doing are you basically just doing rollover night maintenance of existing your transactions?
Yeah, it's a lot of ETL jobs that we're trying to use with SSRS reports and those types of things.
This is probably the easiest solution for your data analysts.
Okay.
Versus rewriting this and to use AFSDK directly. So this particular product is geared towards most of the folks that are in your business side of your operations. So if you're already doing a lot of work in SQL Server, this definitely will help you out. And you definitely want to be using the RTQP version.
Okay, and that would be with a link server using the PySQL client?
Yes.
Okay.
There's these two possibilities. You can use SSIS directly with an ODBC provider. Mm-hmm. So you don't need a linked server. You can use a linked server, but then you would use the ODBC provider from SQL Server further on.
Okay, but if you went the other way, you'd have the RQTP engine.
Yeah, in most cases, you would just go directly and connect from integration services via the data source object to the ODBC provider from PySQL client.
Okay.
Yeah. So, and that works fine. I mean, it's part of our test suite when we release, and yeah, we're supporting that.
Okay.
Any other questions?
Yeah.
Okay, good.
So I've got two questions. My name is Sawyer Fernandez. I'm from Kimball Electronics, an electronic manufacturing company. And we are hosting some data in Pi and exposing that through Power BI so the users can consume that. And Power BI supports ODBC and ODB. So what would be the preference between those two? Or is it the same?
Well, it's actually a question from Microsoft. From my point of view, there is no difference, or very, very little difference. In ODBC, you would typically first define a data source name, well, if you use variant data type, it's better supported in ODB because it's a standard data type in ODB, whereas in ODBC it's a Microsoft extension. But since it's a Microsoft product, I guess it's supported in the same way. So I really don't see much of a difference.
And my second question is, when the user they see all of the tables in all of the folders that they have, we're exposing like all of the tables for the AF elements, and that kind of adds some noise to the users. So I'm wondering if there's any security that can be added so that the users can only see certain views or certain tables with RTQP.
I think it would be solved by catalogs.
Yeah, well, you can probably make your connection with a different default catalog and put views into this catalog. If that completely removes the visibility of the other catalogs, I don't know. That depends on the product. I'm currently not knowing it for Power BI. Some products only show the current catalog. They show only one of many. Some other products allow you to view all available catalogs. But I would try that first. If you can create views in a custom catalog and just connect via the default catalog option in the connection string to that custom catalog.
Next question? I'll grab the mic. Thank you.
So, sorry, I think I came in a little late earlier. So, all this technology, basically, we have to install the RTQP on the AF server. Is that correct?
Yes, yeah.
Okay. Now, is there any version requirement on the AF server? Like, does it have to be 2018 or 2017? Can we install RTQP to enable this by SQL? Or?
Yes, with every AF server version, there is a dedicated RTQP engine version. So the first release was 2018. So AF Server 2018 has the first RTQP engine version, and 2018 SP2 version that was released this week has a new RTQP engine version. And they always come together, so you cannot mix these versions.
Oh, I see. Okay.
Yeah.
So we cannot install RTQP on 2017 AF, for example?
No.
Okay,
No,
got it.
it's not possible.
If you open up the Pi Server 2018 install kit or the 2018 SP2 install kit, the whole feature set is there. And then you just check to make sure that you have the right features. So you have the AF server there, and then you'll see the RTQP engine data access server as a feature. You just make sure that that's installed, and then you're going to be set at all your versions and levels are going to be all checked and then set all at once.
Okay.
And then you'll have all the requirements.
Okay.
I could actually show that part of.
I have that on my server too.
Yeah, can probably connect to. I don't think that many people have seen the 2018 SP2 version, so I'm connecting to a server. So from version 2018 on, there is this integrated setup kit for the Pi server. It's here installed, so I'm going to change it or to go in change mode. And when you do the installation, this is the screens that you see, and there's these individual features here. And here, there's the engine. Yeah, so I don't want to remove it, but it's optional, so you have to select it in order to get it. And what you then get, maybe I'll show you as well. Is the service here that is installed together with the AF service. And
You have your own services account? Where did you get that from? Okay.
You mentioned at the beginning that I'm privileged. So
Yeah.
I not only have Bodo at OSIsoft.com, I also have my service account. So
He has his own data center too.
the default account is a virtual service account, so it comes with RTQP engine as a service account. But you can also, during installation, say I want to use a managed service account or a normal domain account. That's possible as well. So this is basically just for testing here that I'm using my special account. Yeah, so this runs, that's the service. It provides WCF endpoints, so our communication to the client for ODBC and ODB goes via either NetTCP protocol or HTTPS, and for JDBC it's only HTTPS. And the protocol is binary, so we are using the most efficient way of transferring the data to the client. Normally with WCF, you have some HTML or some JSON communication, or XML in general, which is very long because it's kind of text form. We are using binary, so it's really very compressed.
Can I ask one last thing?
Of course.
One last question. So I know we're doing all these things so that the AF data is available on SQL platform, right? So what's the difference between this and Pi integrator where we push from AF to SQL while here we're retrieving?
Yep. So the integrator is specially made for, first of all, connection to other systems and really dumping data into another database. When it goes for comparing functionality from the client side, there is the difference that in the integrator you can pre-create some views. They're called Pi views. Unfortunately, they overlap with views in SQL. But a Pi view is a table that is suitable for BI tool consumption. Mm-hmm. And you can put attributes from all over the AF hierarchy into that table. So you can have the first attribute from element 1 somewhere in the hierarchy, the second attribute from another element somewhere in the hierarchy. So that's what you can do with the integrator. Whereas in the SQL product, we're only template based. So you can only have attributes in your table from the same template. So the integrator is more flexible there, but it's also limited. So the integrator creates tables where the time steps are always equal. So it cannot work with compressed data, for example. So you always have either 1 hour or 1 minute time steps. So it's basically interpolated data. it's suitable for BI consumption, so that's what they want. I mean, the BI tools, they want time steps. They then chunk the data basically in hours or days or time ranges. So that's one dimension is time, and you say, give me the values for the last 1 day, or tell me where I have peaks in production, and you get these time slices. In SQL tools, we are free. We have an archive table with compressed data. We have a table with interpolated data. We have aggregated data. So in this way, it's more flexible on the SQL side. So it's really for different use cases, I would say. Integrator is really so dumping a lot of data in time steps to other systems, and they typically don't know what compressed data is. I mean, in terms of Pi, they're not prepared for it, so they want interpolated data. Like an Excel spreadsheet, typically, every row has 1 minute data. That's what these tools are using. And with our tool, you are more in, let's say, searching for information. You create a query where you have a question to the Pi system. Give me the production value or a certain KPI when some certain condition in Pi was true. So these type of queries are typical. We have our Pi ODBC driver supporting the integrator. So you basically use one of our PySQL family products to plug into a TIBCO or Spotfire. So the mechanism of linking into another system is the same as what we demonstrated here, for example, with the linked server. But it's just a different source. What the ODBC support for integrator is also limited with, it only can go to this predefined table. It cannot do joins between the different tables. So you basically have to configure your integrator upfront so that it puts all the data that you want in your BI analysis in one table. If it's not, if that table is not sufficient, then you have to extend that table first. So there's always this two-phase approach. You first create that table, make sure that the data is sent into that table, and then completely in a separate step, you make use of that table. You can compare it a little bit like with performance equations. You have performance equations. They are continuously running and creating the results, and then you are using the result from another tool, completely independent on the equation scheduler itself. The alternative is you go with PyDataLink and type in a Pi equation and execute it. Right? That's the ad hoc mechanism. And so in the same way, the integrator is like the performance equation scheduled mechanism, whereas the SQL is the ad hoc mechanism. You run the query at the moment in time you need the results. It's in real time. Maybe it takes a little longer. You have to wait for it, but you are flexible to change it any point in time. Whereas if you want changes in the integrator, you really have to go back to the configuration, create another table, or change the design of the table. So it's always this two-step approach there.
Okay. Thank you.
Any other questions? Just pass the mic. Thank you.
Thank you very much for your presentation. I think there's some applause that should be coming because a lot of this looks amazing. Quick question for you on performance tuning. I'm just wondering if you've got a large data set coming back in your result set, long-running query, what recommendations might you have to improve that through like PyArchive file maintenance or other configuration parameters that might be available?
So your question is you're reading a lot of data from the data archive via PyPoint data references. So what can you do to make it even faster? The first thing is I mentioned that we have some streaming in there. that you get the results as soon as possible. If you avoid having an order by clause in the query, then you get the results nearly immediately. If the query is really as simple as, give me the data archive values. If there is no, more complex query involved, really just, from months A to months B, give me the data for 10 attributes. Then if you don't have a resorting of the data, you get it immediately. The result, the first row is nearly immediately there, and you can use the streaming mechanism. If you are in a programming environment, especially, you will be able to go with a cursor through the results and consume it, where the backend still works and retrieves more data from the data archive. You can actually test it nicely with the commander, because the commander makes use of that already. So the first couple of rows are there immediately. Unfortunately, I haven't prepared that performance query here for the demo, but it's very visible there that when the query runs 10 minutes, the first results are there immediately, and then it works in background and then gets the next page,
And PySQL Commander also breaks down by time what's happening in the query, just like it would in a normal if you go in SSMS and do the query analyzer against your own query, you get a breakdown of where the time is being spent.
Yeah,
so there's a query cost analyzer in there.
Yeah, so if I switch my virtual machine maybe here. So the commander here has the execution time. It has actually total time and execution time. So you can see if it's a longer running query, there is a difference between the execution time and the total time. So execution time means when is my query being executed, and the total time is when I have all the data over there. So there might be a big difference between these values, whereas in PyODB Enterprise, these values were always equal. You had to wait until the complete result set was built before you could access it. Yeah. The other thing that we're currently only using for tech support purposes is we also have an execution plan now. That you can look from the commander. We don't make it public at the moment how to do that, but it's possible that you can analyze the execution plan and see where the time is spent on the server. Is it data archive calls, or is it sorting, or is it maybe spent in navigating through the AF hierarchy? So there's things there to help optimize queries. But what we don't have at the moment is these order by clauses. No, not order by. These option force order, which we had in ODBC Enterprise to force the execution in a certain order. So you could in Enterprise say first look in table 1, then look in table 2. By using these clauses. It's not necessary anymore for this engine. So you're automatically getting the best execution plan here.
Are you using cursors to consume from long-running queries already?
Not in the particular example I was thinking of, no.
Okay, yeah, because if you're programmatically consuming it, you probably should open a streaming connection, and then that way your program that's consuming can immediately react and then start farming out the records. Like if you're doing more post-processing of the records, then you probably want to spin up threads as you're receiving the data to go farm it out to do whatever post you're doing.
Yeah, so maybe in the future we can also add some tuning parameters on the server side. They are partly there already, so how many threads, for example, are used to talk to the data archive. Or to the SQL server. That's currently not configurable. We have found our optimum there at the moment, but I could imagine that in different sized Pi servers that there might be some possibility to tune it. So at the moment, actually, there's not much you can do. We hope that we can give you the best performance automatically. Yeah.
We have a few minutes left. Do we have any further questions? Going once? Going twice? All right. Thank you so much, everybody, for coming
All
out.
right. Thank you.